AI is driving data center power sky high from around 15 to over 100 kilowatts per rack. Air cooling can't keep up, so liquid cooling is stepping in. To discuss this today, we have Peter Huang from Castrol and Gaurav Gupta from Gartner. Gentlemen, welcome to the discussion. Why, in your opinion, is liquid cooling more effective than advanced air cooling?
With increasing compute demand, the new chips and the server racks have a higher power requirements. As a result of that, the current air cooling is no longer effective at taking the heat away. Liquid has a much higher specific heat capacity and also a higher thermal conductivity. So it's better at removing the heat away from these high-end servers and chips. And that's why there is a move from air cooling towards liquid cooling. There are various other advantages, including improvement in PUE, reduced cost, and it also provides a much higher compute density.
Liquid cooling is essentially more effective because it has better thermal conductivity. What does that mean? That means it's able to remove the heat more compared to traditional air cooling. Second of all, it's more efficient than traditional air cooling. It's able to remove heat resistance because it's in direct contact with the heat source, which is the chip and the servers. Last but not least, liquid cooling is proven to remove up to 80% of the energy used for cooling the data center. So it's proven to be more efficient.
How is Asia's digital and AI boom reshaping cooling needs in data centers?
AI's digital boom and AI need is definitely changing the way liquid cooling and data centers are designed. First of all, per chip, power density is up to 1,000 watts. We're seeing more of that even in the future. Rack density, as you mentioned, is above 100 kilowatts right now. We're looking at 150, 200, or even more down the line. With that being said, liquid cooling is becoming the necessity. It's the norm. There's no option from it. Maybe there can be a different hybrid system, but liquid cooling definitely needs to play a part. As I mentioned earlier, liquid cooling is able to remove the heat directly with a higher heat conductivity compared to traditional air cooling. So it is a necessary thing for AI and deployments to go for liquid cooling in Asia.
So, as Asia is a developing economy, there is a strong need for high performance compute as well as with the current buzz around Gen AI and agentic AI, the compute requirements continue to grow. As a result of which, there are a number of new data centers as well as AI factories coming up in parts of Asia to run various AI workloads, whether it is training or inference. And with these requirements, as compute increases, air cooling is no longer sufficient, and there is a strong move towards liquid cooling in Asia too. As a result of that, what is going to happen is we will see a new design for data centers which are being built now as well as in the future. Plus, there is issues around water scarcity, availability of power, etc., which are some of the constraints with the new data centers, and liquid cooling will help in that regard too.
What changes will we see in data center design as liquid cooling becomes mainstream?
In terms of the design, I think it's a complete new way of looking at the data centers. You won't require the raised floors any longer. Plus, there will be a lot of new plumbing that will be required to bring water inside the data centers. Liquid cooling, if used in closed loops, can also get rid of evaporative method of cooling, which combines with air cooling, and that consumes a lot of water. Now, with liquid cooling, the entire IT infrastructure servers have to be reconfigured, re-optimized, and it's just a completely new way of design. These buildings will have a much better PUE and will reduce the use of electricity. We will also see a completely new design in terms of the requirements for liquid cooling, like CDUs, manifolds, entire new plumbing, built-in intelligence to control the pressure, temperature, flow for the liquid.
There are three parts. First is space. As liquid cooling becomes mainstream, space is becoming smaller. The use of space, how to optimize the space, is becoming a big design question and trend for people around Asia. Liquid cooling requires less space, it's requiring more compact design, and the piping design is very different from traditional air cooling. Second is on energy. Liquid cooling is able to remove up to 80% of the energy. With that being said, more energy is going to pump into the servers and the chips for more computing power. It also means that the PUE, power usage efficiency of data center designs across Asia is going to be lower. We see many mandates from different countries requiring it to be lower than 1.2, right? Lastly, sustainable cost optimization. Liquid cooling is proven to have lower TCO, total cost of ownership, throughout the life cycle of data center. So it's definitely changing the way how design of the data center works.
Well, thank you very much to both of you, gentlemen, for sharing your insights with us today, Peter and Gaurav.
No problem. Thank you very much for having me.
Yeah, thank you for having me here.
Once again, our guests were Peter Huang, Global President of Thermal Management and Data Center at Castrol, and Gaurav Gupta, VP Analyst at Gartner. For more news, please visit asiantelecom.com.